Greetings, friends. Happy pre-spring break lab, or possibly actual spring break lab if you're doing this during break. For me, it's the Friday before, so we're going to get you started here with lab 8 and doing some calorimetry this time around. So I've got my experimental setup here, my experimental lab bench. In your lab kit, you'll have a couple of cups. You should have 3. I'm going to reserve a double for the to kind of give it a little more insulation for the actual mixture part. And what I also have here, the thermometer, which comes with it. You'll need some ice cubes and some hot water. I've got my kettle back here, and then spoon just in case you need to fish things out of hot or cold water. So and also measuring cup, right? So first part is it may seem fairly straightforward, and I guess it kind of is supposed to be, which is to take a certain amount of cold water, 200 mils in this case, and then 100 mils of hot water, and just mix them together. Experimentally, find out what is the final temperature of that, and then go do the calculation and predict, according to what the math tells us, predict what the final temperature should be, measure what the final temperature actually is, and then compare those two. So in the lab, I give you the specific heat of the water, which is 4186 if you like kilograms, or it's just 4.186 if you like joules per gram per centigrade. That works too. A couple of basic things here in part 1. We're going to start with 200 mils of cold water, and I suggest getting it pretty close to 0, like maybe as close as you can go. I'm at 4 right now on this one. So I'm just kind of putting in some ice cubes and trying to get the temperature down a little bit more, and I am practicing bad chemistry technique here by stirring with the thermometer. You may want to stir with a spoon. That would probably be the better thing to do, because you don't want your thermometer breaking. And then after that, what I'm going to do is dump out 200 mils of this into here and pop it into there. And then I'm going to pop 100 mils of hot water into here. And I want to get that pretty close to about 80, maybe 90 centigrade. What you want to do is try to, as best you can, measure the volumes of the water so that you can convert them into masses, measure the initial temperatures as best you can, and then measure the final temperature, okay? Once you've got all that data, you can use the math to predict what the final temperature should be and then compare it to the actual final temperature. See how well we did with the predictions, all right? See if they come out reasonably close. So a couple of things to think about here. I am going to measure the temperatures prior to dropping them into other things. I'm down to 3 now. I would definitely suggest get this as close to 0 as you can for uncertainty's sake, and we will talk a little bit more about uncertainty as time goes on. But here I've got my kettle. So I'm going to measure out 150 mils of hot water. No, this is the first, that's for part 2. 100 mils for part 1. I keep saying 150, but 100, that is as good as I'm going to get with that. So now I'm just going to pop the temperature of this real quick. It's going to go firing way up. And we are rolling here up above. Keeps going, keeps going. I do recommend just kind of stirring things to keep the temperature of the water consistent, just so you don't have a cooler or a hotter pocket of water right there. All right, so I'm up about, I'm up here about 84 degrees. Okay, so what I'm going to do is I'm going to take my 200 mils of water. I'm going to take the ice cube out because we don't want that. Where did it go? There it is. We don't want that. Come here. We don't want that in there. All right, so I'm going to pour the hot water into here. All right, I'm just gonna dump the ice out. I've got my 200 mils pre-measured in here, but I'm just gonna check it because I think just to make sure that no ice melted. All right, okay. Yeah, it looks like a little bit of the ice made it. Okay, so there's 200 mils. We're gonna pop these together and stir them up and see what the final temperature looks like. Alrighty, as it goes up, up, up a little bit more. Okay, so you're just gonna kind of stir this up, get the temperature hopefully nice and consistent throughout the liquid, and then compare your reading here on the thermometer to your calculation. And while you're doing that, I do suggest you think through what uncertainties were incurred as you did the experiment. So what would you say, how well did you read the volume? Was it to plus or minus 1 gram of water? Probably not. How about the temperatures? Was it plus or minus 10 degrees? Well, I think you could probably do better than that. So try to make some estimates of the uncertainties, because more than likely you're not going to get perfect agreement. But the idea is, do you get agreement within your uncertainties? Okay? Because the true value will lie somewhere within your uncertainty range. So part one is just hot water into cold water, figure out the final temperature, and predict. Okay? Part two here is I'm just going to reboil my water and get ready for part two here. So we're going to take the aluminum squares. Okay, you should have 2 of these, and I would suggest, mine had plastic wrap on, so I would suggest remove that first. You should have both of these available. Let me just grab, where's my other one here? Here we go. Okay, you should have your 2 aluminum squares. What we're going to do here in part 2 is try to figure out what is the aluminum's specific heat capacity. All right, so I'm just going to pause real quick while I get ready for part 2 and get my water started. Alrighty, I'm back for part 2, though no time has passed for you. So what we have for part 2 is we're going to take those aluminum squares. I have them submerged. This is cold. This is water with ice cubes in it. It doesn't matter how much, just something so you can get ice cubes. You just need to cool these things off. And your goal is to shoot for pretty close to zero as you can get. Right now I'm reading 2, which is pretty good. I just put another ice cube in there, so hopefully that'll drop it down a little bit more. But this is not important. This is just a bath to get the aluminum to 0. And the water that you're going to be dumping it into is 150 mils of hot water. So I just have this freshly boiled, and I'm going to pour out 150 mils of this right to about right there. So I got 150 milliliters of this, and I'm going to put that into the cup. And I'm just going to see. Okay, well, that's good. We're down to 1. All right, even better. I'm going to put it in here, see what the temperature of this is. I do recommend that you pour it into there because this cup will be at a different temperature, so it will affect the temperature of the water as the heat leaves the water in order to heat the cup up. And now with this, we are, oh yeah, this is pretty good. We're at 87, 80, man. Boy, these hash marks are pretty close together. I'm going to go 87 on this one. All right, so I'm just going to stir that up, keep it at hopefully at a constant 87 centigrade. And I'm going to go back here, take another quick look at this. And by golly, that's going way back down, and I'm at 1. I think it's falling a little bit under 1. Okay, I'm going to call that basically just about 0. So what we're going to do is I'm going to get the aluminum squares out of here, and I'm going to put them in the hot water. These are at 0 centigrade right now. Come on, these are at 0 centigrade. And so I'm going to take them and put them into the hot water. I'm just keep them in. All right. Yeah, I know. I'm touching them right now. I'm going to put them in the hot water, and then we're going to do the same thing as we did in the last section, which is to measure the final equilibrium temperature. Now, hopefully you're not going to spend as much time doing this as I am while I'm talking to you, so your process might be a lot better. than mine, because I took data and it was a few minutes ago by the time I got these in here. So here we go. There's number 1 and there's number 2. We do that quickly as possible and off we go with the temperature. Yep. And we're just going to wait for it to equilibrate, which in other words means it's going to fall, and you're looking for it to stop falling and kind of reach its spot, and then it'll probably start to drop again, right? Because this is definitely losing heat to the environment. So what you're looking to try and do is see what do you think is the best indication of the final temperature that you can get here. So we're down, it's gone down, I don't know, I'm in the 70s here somewhere, I think, yeah, 71, okay. So anyways, you go ahead and take cold aluminum, put it into hot water, and then read the final temperature and see how it goes. Now in this section, I'd like for you to, again, think through the same types of uncertainties as you did in the first one. In other words, how much different could the mass of the water be from 150? Could it be 152? Could it be 175? Right? I have to say I don't think it could be, because I have a 175 marker on my jug here, so it's definitely not off by that much. But I probably, and I definitely was less than half that. So I might say it's plus minus 5 to 10 mils. I don't know. You know, it's up to you. Do the best you can in order to try and estimate what you think your uncertainties are. In the lab, I give you the masses of the aluminum squares. Those were taken at the lab before we mailed them out. So we have our precise scales. So it was 45 plus or minus 1. So together it's 90 plus or minus 2. And so you'll think, okay, well, now I've got a certain amount of uncertainty built into just the masses of those things. The goal, remember, was to try and find the specific heat of the aluminum, knowing the specific heat of water, the masses involved of the water and the aluminum, and the temperatures involved, which were the initials of both, and then the final equilibrium temperature. So having all of that data, want to try and find out what the specific heat of aluminum is according to this data. So how far off do you think the aluminum specific heat could be from the actual value, which you can certainly look up, and I think it's around 930 joules per kilogram per centigrade. So would that be within the range that you find? And I'm just citing that number off the top of my head. I think that's what it is, but I don't know for sure. You probably just want to verify that. When you complete the table that's in the lab regarding all of the uncertainties that you have, right, there's a table here saying estimated plus minus and what ultimately is the percent. Try to pick the one that has the biggest possible percentage in it, okay, and then say that that percentage is the uncertainty in your specific heat of the aluminum. That will give you the ability to then find out how big the plus or minus absolute uncertainty is in your specific heat. In other words, if I use the percentage and I say, oh, I'm going to be off by 10%, well, that is that gives you a way to calculate what the plus minus range is going to be. So suppose I came up with, 800 as my specific heat, 800 joules per kilogram per centigrade. Well, if I'm off by 10%, then the range is 720 to 880. Okay, so you can say it's plus or minus, it's 800 plus or minus 80. Or you could say the range, like I said, was 720 to 880 or something like that, where you have a range in which you can try and compare the quote unquote given value that you search off the internet for and see if it falls within your experimental uncertainty. All right. So other than that, that's basically the mechanics of this lab in particular, trying to look for a final temperature in part 1 and a specific heat of aluminum in part 2. And then please think about your uncertainties and report out on how that goes. If there are parts where you think, well, we could improve the we could improve either the actual experimental techniques, or there's a better way to do this, or something like that. Please do make suggestions, and because we are ultimately trying to improve these labs, and let me know if you think that will improve the uncertainty in the lab, or if it will maybe get better results, or what do you think is going to happen? In terms of timeline, we are heading into spring break as I am making this, because this, like I said, is the Friday before. And remember that we are off the Tuesday of the week that we get back, which means I don't see you till Wednesday. So that'll be when the lab's due, on Wednesday of the week after next. Okay? So you'll have plenty of time to do this. And that due date is reflected in the Canvas assignment. So what do I say? Good luck. I hope you will enjoy, are enjoying, or have enjoyed a pleasant spring break. And enjoy a little bit of time mixing some water, hot and cold together, and then mixing a little bit of aluminum squares with your hot water and seeing how you do. All right, well, good luck, and I will talk to you again at the resumption of classes on Wednesday, April 1st, April Fool's Day. All right, happy rest of your day or your week. Hopefully it'll be nice. Hopefully it was nice. Hopefully it is nice. See you next time.